Hi, this is Shannon Prey, and I am doing fluency response number 1. And here we go. I've intentionally studied, taught, and learned science for the last 40 of my 46 years on this planet. Until now, I focused on the big ones in science: chemistry, physics, biology, earth science. And many of the scientists in this field consider other things such as psychology, sociology, anthropology, soft sciences. They don't even, in some cases, consider them sciences at all. Some of them consider those pseudosciences. So, what is science? Science is a systematic exploration or study of the natural world using description, prediction, and control that relies on determinism as its fundamental assumption, empiricism as its prime directive, experimentation as its basic strategy, replication as its necessary requirement for believability, parsimony as its conservative value, and philosophic doubt as its guiding conscience. That's a lot. Let's start taking that apart. What is science not? Science is not feelings, beliefs, religion, hunches, guesses, or decisions. Is psychology a science? Yes. Obviously, it ends in ology, so it has to be a science. So let's dig a little deeper into what science is. Science has 3 levels of understanding. Description. So this is going to be making observations. What those observations do is they lead a little more into more questions, and they give you a look at what's out there so you can make some hypotheses, not guesses, hypotheses. And then the next level is prediction. This happens when you repeat observations over and over again and you start to see some connections or covary. These events can lead to development of a correlation. This does not make a causal relationship. Control is the next and highest level of scientific understanding. This is when functional relations can be derived. This means if this is true, then this also has to be true, or if this is true, this cannot be true. We use these functional relationships to manipulate our world. These 3 levels of understanding are not unlike Bloom's taxonomy in teaching. So if you know anything about teaching in Bloom's taxonomy, there are levels of understanding that we try to take kids through to reach the highest level of understanding or a highest level of critical thinking. The first one is remembering. This is basic, like rote memory. Here's flashcards, memorize these terms. And then there's understanding, applying, analyzing, evaluating, and creating. So the first 3, remembering, understanding, and applying, those are the first 2, remembering and understanding, those are most like observing. The next 2, applying and analyzing, those are going to be most like predicting. And sometimes the 5th one, evaluating. And the 5th one I kind of leave back and forth between predicting and controlling, because evaluating goes a little bit into both. And then finally, creating ties most in with controlling. I can kind of see a relationship in both of those. As described in our definition of science, there are several basic assumptions shared by scientists, and contrary to the popular saying, they prevent us making an ass of ourselves. Determinism tells us the universe is lawful and orderly. As an example would be, what goes up must come down. Empiricism, we use objective observations and measurements. For example, we don't say a water bottle is pretty. We say that the water bottle is 64 ounces, 4.7 inches by 11.3 inches. It's pink. It has a dual steel wall. It's BPA free. It has a screw top, and the spout is a chug spout. And the handle is made of woven plastic. This is a totally made-up water bottle. I didn't use any source for that. I just made it up in my head. The next one is experimentation. It's a basic strategy for solving problems in science. And this is the one most people think of when they think of science and the scientific method. So we all experiment every day in our everyday lives. Everyone is a scientist, whether they know it or not. Even something as simple as, does this necklace look good with my outfit? No, let me try another one. The dependent variable is your satisfaction with your outfit. The independent variable is the necklace you choose. Your controls are the person wearing it, the outfit, the day. There's tons of controls in that situation. But every single person is a scientist, and they do experiments every day, and they use logic. Whether they use their powers for good or evil are up to them. Parsimony, keep it simple, stupid. The simplest answer must be ruled out before you can look for a more abstract and complex answer. And philosophical doubt. I love this one. In this one, you're always looking to prove yourself wrong. You're looking to prove someone else wrong. And science is more fun this way because you get to do more experiments. You're looking to solve more problems. You're learning more. I like that one the best. So what is applied behavioral analysis? This is the development of technology, and it's used for improving behaviors. Is this a science? Absolutely. Not just because it has the words technology in it. Applied behavioral analysis evolved into science thanks in start to a guy named Watson, John Watson, and he's not any relation to the John Watson in the Sherlock Holmes stories. He developed stimulus response psychology, and this is a form of behaviorism, but we're not quite yet into applied behaviorism or even experimental behaviorism, which came about through B.F. Skinner. He wrote a lot and he did a lot. Among his many accomplishments were the development of ideas of respondent behavior, operant behavior, experimental behavior analysis, and radical behaviorism. And from his rapid-paced and early studies in behaviorism came a guy named Fuller. And Fuller did the first experiment in applied behavioral analysis. But it wasn't quite applied behavioral analysis yet because it wasn't useful in society. What he did is he took a syringe, filled it with sugary milk, and he gave it to what was called at the time a vegetative idiot. This guy laid on his back all day. He didn't move a lot. He didn't use his right arm hardly at all. But when he was given this milk solution every time he moved his right arm, after 4 sessions, he started raising his arm about 3 inches higher, or 3 times per hour, 3 times more, and he was raising it higher than before. So they found that he was doing this experiment in behaviorism, but it was not yet applied behavioral analysis. To be applied behavioral analysis, it needed to be socially significant and useful. Since this experiment was done, the same principles that were applied have been applied to socially required or socially useful, such as people with disabilities waving their arm for the bus, or I apologize. In a quote by Neef in 2002, the same principles that were applied in Fuller's 1949 study to increase arm raising of a young man with disabilities while lying in bed have been applied to teach arm raising of others with disabilities, to signal a bus on their way to work, to get a waiter's attention in restaurants, and to answer teachers' questions in the classroom. Shortly after, in the 1950s and 1960s, the field started to grow rapidly, with colleges starting programs, studies being done, and works published. Around this time, the godfathers, quote unquote, of applied behavior analysis said that applied behavioral analysis has been applied to behavioral, analytic, technological, conceptually systematic, effective, generalized, and socially significant to be applied behavioral analysis. And at this time, this is when applied behavioral analysis became a true science. And this is useful in my real life when I am teaching my neurodivergent son, helping him with his homework. I use a positive reward system. When he uses his planner, he gets his favorite thing are video games. He gets screen time on his video games, and that has been his most successful reward when he gets his reward time on his screens, and that has been very successful. So that is my real life example of using applied behavioral analysis in my home.